So on to a Circle Theorem's question 19. So we're given some information about our circle. We've got A, B, C, D, which is a quadrilateral, touching the edge of a circle, so it's a cyclic quadrilateral. That will help us find some missing angles, knowing that. We've got to write down the size of the angle BAD on this one, and we've got to give a reason for our answer. Well, BAD is opposite BCD, and opposite angles inside a cyclic quadrilateral add up to 180. So 130 plus angle BAD equals 180. So I think that's pretty obvious, it's going to be 50, and the reason is because opposite angles in a, they won't punish you too much for a spelling mistake. Quadrilateral equal 180. So they want the opposite angle cyclic quadrilateral. Now for 4 marks, so this must be a bit more difficult, work out the size of angle ODC. ODC. Now, we have got an angle coming, now we've worked out our angle here, 50. And that's coming off the arc BO, so that's coming off the arc BD. Now BD also goes to the centre at O. We should know that the reason that the angle at the centre is double the angle at the edge. Right, so I'm going to write that down. So I'm going to say BOD equals 100, angle at the centre double angle at edge of the same arc on a circle. Now they might not need it to be quite as full as that, but that's me giving you full information there. So that gives us 100. Now we've now got the fact that this is isosceles to take into account. So draw a line across there. Because this is an isosceles triangle, this is going to make these two 130, so we've got 50 to make up, so we're going to have 25 there and 25 there. Now we want, in fact, what do we want? ODC. ODC. So I've got, and also you'll notice that this, and that's the hard one to spot sometimes, they're going to the centre. So they haven't marked in that they're isosceles, they're expecting you to realise that you've got a radius and a radius. And now with that you've got 80 to make up, so you've got 40 and 40. And so with that, with the 40 and 40, we've now got the angle we want, ODC. So ODC equals 40 plus 25. And I'm writing that off the page, so let's straighten that out for you. So ODC, we'll write it up here next to the diagram itself. We'll come a bit closer to the diagram so you can see everything. Let's get that right. So we've got ODC. ODC consists, we've got two isosceles triangles. We get the 25 and 25 because we know it's 130 here. We've already got the 100 from the double angle at this double, the angle at the centre is double the angle at the edge of the same arc BD. And then it's this bit here that's the tricky bit, realising you've got two radiuses there. And then if that's 100, these two are the same, we must make 40. And so your angle ODC equals 65. 65 equals 40. Okay, it's the 40 plus 25. So the reasons then, so if we come down to the reasons I've given earlier, so BOD is 100, angle at the centre, double the angle at the edge. ODC at 40 plus 25 from the isosceles triangles. I think it's fairly obvious in the work that you've marked in the isosceles triangles, and you've deduced the other angles from that. So that's your 6 marks for question 19.